Okay, moving on. Let's go back real quick and look at the work from yesterday. Okay, this was the bell curve that we filled out together. Okay, here's the answers. So this is page 8. So go back and check to make sure you got your percentages or your ranges right. Give y'all a minute to look over that to make sure. So I can show you the ranges right there too. Okay, so now let's flip over to page 9. Okay, some questions. These are good questions that could be asked on a test. Given an approximate normal distribution, what percentage of all values are less than one standard deviation away from the mean? Okay, so if I'm thinking about my normal bell curve, okay, if I'm thinking about my curve, if I take one standard deviation step away, okay, if I take one step away, so think about our picture right here, I'm talking about 68% of my data. Okay, so 68% falls between that one standard deviation. Okay, the next is two standard deviations. So if I take two steps, I am talking about 95% of my data. And then, of course, the next step out was almost all of it, 99.7. Okay, these are good to remember. One step, 68, two steps, 95, three steps, 99.7. So those are good things to, I would say memorize, but again, since you get to use your packets, there's no need for memorization like I had to do. Okay, so let's look at this next curve. Okay, this next bell curve, they want us to set up with a mean of 175 and a standard deviation of 37. Remember, every step to the right, we add that standard deviation. And every step to the left, we subtract. Okay, set up my mean, set up my standard deviation, and we are going to fill in our percentages. So I can easily answer these questions down here. Okay, what percent falls between 138 and 212? Okay, y'all know where the colored pencils are. You know where the markers are in my room if you want to use them. Okay, again, 138 to 212. Those two percentages right there make up 68%. Ooh, yellow, not a good color. Okay, so 68%. Within 101, all the way up here to 249. So from 101 to 249. And I got 95%. Okay, 64 and 286. So from 64 all the way out here to 286. Okay, remember my shortcut method. Sometimes it's easier to take the entire curve and subtract what they're not asking for. Okay, and in this case, they are not asking for the two tiny little tails. So neither one of these little 0.15 tails are included. So 99.7 and 138 to 212. It's 34, 34, 13.5 is 81.5. Oops. $100 to $249. 95%. And last one on this page from 64 all the way to 286. Oh, oh look, I've done those wrong. Okay, these are asking for the percentages outside of those values. I am totally wrong here. Okay, so they want everything outside of 138 to 212. Okay, from 138 to 212 is right here. So everything except that 68%. Okay, so they want everything except those two percentages right there. My fault. Okay, so they're talking about 32%. That's my fault right there. Okay, outside of this interval, outside of 100 up to 249. Okay, outside of that, so we are talking about just the 2.35. 2.35 plus 2.35 plus the little 0.15, so we are talking about 5%. Okay, in the last range, 64 all the way up to 286. So the only two values that are not included is the two little 0.15s, which leaves us with my pen is messing up. Y'all see that? Which leaves us with the little 0.3. 0.15, 0.15 is 0.3. So it leaves us with 0.3%. Not 30, just 0.3, a tiny little amount. Okay, so that was kind of a quick review of yesterday. Be careful, read the questions, unlike me who just jumped right into it and ended up doing them wrong. Okay, read the questions. Okay, flip it over. We are going to talk about z-score. Okay, it says, suppose Sarah took a quiz in her literature class and scored a 70 out of 100. She's asking her teacher how well she did on the quiz compared to the other 50 students in her class. Okay, if the quiz scores are normally distributed and the average score was 60, then at first sight it may appear that since Sarah has scored 10 points above the average, that she achieved one of the best grades. Okay, this does not, however, consider the variation in scores among the 50 students. In other words, what we know is a standard deviation. Okay, it doesn't take that into account. Okay, suppose that the standard deviation was 15. Okay, the average quiz score was 60, so let's go ahead and put that on there. The average score was 60 with a standard deviation of 15. So we're going to add our standard deviation in this direction again. Okay, and subtract the standard deviation in the other direction. Okay? So now that our box is set up, okay, it says supposed standard deviation is 15. Use the empirical rule to find what percentage of students actually scored higher than Sarah and what percentage scored lower than Sarah. Okay, there's a problem. Okay, Sarah scored a 70. Okay, I don't see 70 on here like it was in the past problems that we've done. Before, if I asked you, let's say this was test scores, another super high, but let's say Sarah scored a 212. Okay, you could easily go to 212, add up the percentages, and realize how many people got higher than her. Not the same here. Okay, it is not a set step away, so I can't exactly calculate the percentage the way I did it before. Okay, what I can do is calculate something called the z-score. Okay, it's a really easy calculation. Okay, my paper's actually cut off. Hang on one second. Okay, so we have to calculate Sarah's z-score. Okay, again, our little formula got cut off right here, so I'm going to write it up here. Okay, we have our Sarah's score is going to be our x. Our x is going to stand for our score. Over, let's list it like this. Our score minus our mean, because that's what we're used to seeing, over our cute little standard deviation. Okay, that's going to give you your z-score. Okay, so again, we have our number minus our mean over our standard deviation. And that gives you your z-score. Okay, number minus our average divided by our standard deviation gives us our z-score. So let's use this information real quick just to calculate Sarah's z-score. Okay, so let's say that we know that Sarah scored a 70. Okay, they told us that the class average was a 60 with a standard deviation of 15. Okay, if you use your alpha y equals in the calculator, it'll pull up that n over d, which will make it easy to do this in one step. So 70 minus 60 over 15 gives us a z-score of 2/3. Okay, which in a decimal form is 0.67. Okay, so that actually tells us how many standard deviations away from the mean that Sarah is. Okay, that's how far her score actually was from the mean. Okay, one step away, one full standard deviation away puts her at a score of 75. Okay, Sarah scored a 70. Okay, so Sarah has to be between 0 and 1 standard deviation away from the mean, and we know that she was exactly 0.67 standard deviations away from the mean. Okay, so just guesstimation, that would put Sarah's test score about right there. Okay, again, total guesstimation, score is about going to fall right there. Okay, flip it over and let's calculate some more z-scores. Okay, again, I'm going to put this at the top. Z-score. Okay, so now that we know what Sarah's z-score was, now you can use your handy little calculator to actually calculate her percentage. Okay, again, remember before, if it was an exact standard deviation away, we could easily calculate the percentages because we knew those. We knew the 34, we knew the 13.5. Okay, once we throw a wrench into the system and put somebody in between, then we don't exactly know. Okay, but given our trusty little calculators here that are awesome and can help us figure this out, we're going to go ahead and do it in the calculator. Okay, so we are going to pull up our calculator. Okay, so looking at these charts right here, or these bell curves, sorry. Okay, we are trying to figure out the actual test score or the quiz score of the kids that were in the 90th percentile. Okay, what's her name? Sarah. Okay, Sarah wants to go home and brag to her mom that she made a 70, which was higher than the average, and let's say she wants to go in and say she was in the 90th percentile. Okay, well, that's not 100% true. We need to figure out what the 90th percentile was. Okay, so we are going to pull up our trusty little calculator. Okay, and like I said, it will do all of this for you. We are going to hit some buttons here. Okay, so you are going to hit the second button. Okay, our trusty little blue fella. Okay, so we're going to hit second. And then we are going to hit that vars button. Okay, second vars. Let me do that again. Okay, second vars, and it pulls up all these options for distribution. If you see right there, DISTR stands for distribution. Okay, and we are going to scroll down to inverse norm. Okay, the inverse norm, and it is going to show you the exact same screen that you see on your paper. Okay, and if we want to know the number or the percentile of 90% as a decimal, it is 0.9. We are going to leave everything else the same. Okay, inverse norm. Come down here and click paste. And we figured out that 90% of the data, okay, 90%, because we know 68%, we know 95%, we know 99.7%, and of course we know 100. Okay, 90% is a different percentage than what we're used to. Okay, 90% of the data falls 1.28 standard deviations away from the average. Okay, so it has a z-score. Remember, z-score tells us how far away from the mean it is. Okay, so a 90th percentile has a z-score, or a standard deviation step, for lack of a better word, of 1.28. Okay, so again, we hit second vars, and then in the area section, we entered the percent as a decimal. Into area. And then we scroll down to paste. We didn't mess with anything else. Okay, again, let's do that again. Second vars. Oh, I forgot to put inverse norm. Scroll down to inverse norm. Inverse norm, hit enter. Add our percent as a decimal. Scroll down to paste. And hit enter. Okay, so this gives us a z-score of 1.28. Okay, so 1.28. So, what did we say Sarah's z-score was? Let's go back to Sarah. Okay, Sarah had a z-score of 0.67. In order for Sarah to correctly state that she was in the 90th percentile, her z-score would have to be a 1.28 or higher. Okay, her z-score would have to be a 1.28 or higher. Okay, was Sarah's z-score within a 1.28 or higher? No, absolutely not. Okay, she got a 0.68. Okay, you do not have to do this, but I'm going to see what the actual test score was if you had a 1.28. Okay, I know my standard deviation was 15 with a z-score of 1.28. That actually puts you 18.75 points away from the average. Again, you do not have to do this. I'm just doing this for fun. The average was 60. I'm going to add my points. So that means that Sarah would have actually had to have made a 78.75 in order to be able to go home and tell her parents that she was in the 90th percent for test grade. Okay, so yes, she was above average, but she wasn't superstar like she thought she was. Okay, so flip it to the next page. We're just going to do some practice with this. Okay, find the z-scores. Again, I'm going to put that up here. Your score minus your average divided by the standard deviation gives you your z-score. Okay, find the z-scores for each of the following with a mean of 30 and a standard deviation of 5. Okay, so the very first one, I have a score of 39 minus my average of 30, and then I divide by my standard deviation of 5. So my first person had a z-score of 1.8. Okay, and again, this is how I set it up. 39 minus my average of 30 divided by my standard deviation of 5 gave me my z-score of 1.8. Okay, this guy, 17 minus 30 over 5 over 5 or divided by 5 gives me a z-score of negative 2.6. Okay, don't freak out that it's negative. Remember, on our bell curve, we move to the left. Okay, anytime we move to the left, it gives us a negative z-score. Okay, do not freak out. That just literally tells you that you are moving to the left. Okay, 42 minus 30 over 5. Gives a z-score of 2.4. Let me show you real quick. If you're doing this in alpha y equals 42 minus 30 on top over 5 on the bottom, it's going to give you a fraction. Okay, if you hit the math button, which is right here under alpha, and then the second choice tells you to change it to a decimal, okay, then it will change it to that 2.4 for you. Just another option if you want to use it. Okay, this one we have a different average and a different standard deviation. Okay, to find the z-score, it's not going to change. 12 minus our average divided by the standard deviation. 12 minus our average divided by the standard deviation. So we have a z-score of negative 1.33. 21 minus our average over the standard deviation. $1.67. $13 minus our average and give us another negative z-score, which again is totally fine. And he gives us a z-score of negative 1. Okay, the next one is what I thought we were doing a minute ago, but we weren't. We were actually calculating more z-scores using or calculating 90th percentile z-scores, sorry. Okay, this one is a little different. This one is actually going to give us the percentage knowing the z-score. Okay, still using your calculator. I'm going to write the steps out here to the side. Remember, anytime I write steps, y'all need to write the steps out to the side. Okay, so I'm going to jot the steps up here real quick so y'all can see them. Okay, and there are two different things. We have it to the left of, so think of your bell curve. Okay, here's your bell curve. To the left is going to be this direction, and of course to the right is going to be anything above. Okay, so we have left and the word below, fall this way, and then we have right and the word above. Okay, so anytime you see those two things, you got to think about it. Okay, so in order to calculate this, given the z-score, you are going to put in your calculator, and you are going to hit the second button, vars again, and this time we are going to do option 2. Okay, second vars. This time we are going to do option 2, which is a normal distribution curve. Okay, and hit enter. And we have to ask ourselves, where are we? Are we looking for things above us? Or are we looking for things below us? Okay, so this is saying to the left of 2.91. Okay, to the left of 2.91. So let's say 2.91, I really have no idea. Let's say it falls right here. Okay, so I'm looking for everything below that, everything to the left of 2.91, which means I have no idea what my lower value is. Okay, I have no idea what my lower value is. So we're going to do this. If it says to the left of, over here to your little steps, we are going to enter negative 999,999 into the lower category. Okay, so negative 999,999. Okay, because I don't know what that is. Okay, in my upper part, we are going to put our upper z-score of 2.91. Okay, then, so we're going to put, then enter z-score in the upper part. Okay, so we did that. We're going to go down and hit paste. Hit enter again, and there it tells us 0.9981. Okay, 0.9981. So let's say almost 1, which would be 100%. Okay, so 0.9981. Change that to a percentage, and it basically is 99.81%. Okay, let's jump down to B and do the to the right of. It's going to be the exact opposite of what we did here. Okay, so to the left of, we entered negative 999,999 into the lower part, and the z-score was the upper. So if we are going to the right of, we're going to do the exact opposite of that. Okay, so second vars, go down to option number 2. Okay, this time I know my lower. Okay, my lower is 0.97. Okay, I don't know my upper, so I'm going to add a positive 999,999, meaning I want it to go forever in the positive direction. Okay, so I'm going to add that over here to our steps. Okay, if it says to right of, you enter in upper, and the z-score in lower. Okay, and then we went down and hit paste. And of course we hit enter. Okay, so when we do that, let's see what we get. I've got my z-score in my lower. There's my upper. I'm going to go down to paste and hit enter. And I end up with 0.166. Okay, 0.166. So if I am to the right of 0.97 on whatever curve that they have that they are not showing us, okay, to the right of that, then I am talking about a percentage of 16.6%. Okay, 16.6. Let's skip C for a second and jump over here to D. Okay, D is asking us for a to the left of again. Oopsie, sorry. To the left of. Okay, so I'm going to go second bars down to option 2. Over here in my notes, it says if it's to the left of, then I enter that negative big number into my lower, and my upper is negative 2.84. Down to paste, and hit enter, and then it gives me a percent. Okay, or not a percent, it gives me a decimal. 0.002. Okay, so 0.002, which gives me a percent of, move the decimal 2 places, 0.2%. Okay, that's a tiny little amount, but it still accounts for something. Okay, we have 0.15 on there, so why not have 0.2? Okay, another to the right of, second bars, normal. Okay, to the right of, over here on your notes, you enter that big number into the upper and your z-score into the lower. So I have negative 1.74 is my low, and my upper is unknown. I want to know to the right of, so pretty much infinite. Down to paste, enter. 0.959, so 0.96, which is 96%. Okay, these are much more fun to do. That's why I save those for last. When we are talking about a between, second bars, okay, you know what your lower is and you know what your upper is. Okay, between 2.53 and 3.09. So my lower is obviously my smaller number, 2.53. And my upper is 3.09. I want to know what percent is going on in between those two numbers. Paste, enter, 0.0047. Okay, again, move the decimal 2 places, so 0.47%. Another between, second bars, normal, enter. Okay, my lower this time is negative 2.14. And my upper is negative 1.95. Go down to paste, hit enter, and I get 0.0094. So 0.94%, almost 1%. Okay, number 4 is asking you the same thing, except it is listed as using our greater than, less than symbols. Okay, so remember, this is a less than, or to the left of. This is a greater, or right. Okay, obviously if there is a z in between, then we are talking about a between. Okay, so this one wants to know with a z-score to the left of or less than 0.43333. Okay, so to the left of or less than that. So we are going over here to the left of, and we are entering it just like that. Bars, second choice. Okay, so less than 0.433, so I don't know what my lower is. And I know that my upper is that 0.43. Down to paste. And 0.667. We're going to round that so we don't get struck by lightning. Which is 66.7% is less than 0.43. Okay, B is greater than or to the right of. Greater than or to the right of. Normal. This time I know my lower is 2.92. I don't know what my upper is. And go down and paste it. 0.0017 or 0.17%. Okay, last two and then we are done. Okay, I have, oh, in the world. I have my in-between here. My favorites, easiest to do. Okay, I'm looking for a z in between 0.75 and 1.86. Not a z, sorry, I'm looking for the probability, the percentage. Okay, and that is 0.19, I'm sorry, I lost it. 0.195. Percentage-wise, 19.5%. And lastly, greater than that. So my lower is accounted for, and I don't know how high. Okay, so my lower is 1.6. My upper is the unknown, so we're going to give it a big old number. Go down and paste it. And 0.054. Which is 5.4%. Okay, again, make sure you have these steps written down over here that I have written in white on this side. Go ahead and make sure you have those written down. And that is going to be it for today. Let's actually go back and list what we put for just a couple of these. Okay, so like for this one, our lower, okay, we wanted everything less than that, so our lower was the negative big number. And our upper was the 0.43. Okay, for this one, our lower was our z-score. And our upper was our big number. Okay, for this one, our lower was the 0.75, and our upper was the 1.86. Just want to make sure y'all have this on here somewhere so you can refer to it later. This one, the lower was our z-score, and the upper was our unknown. Okay, remember how to get there. Again, make sure you have these written down.